Hello, everybody. This is our last class online. Well, my last instruction. We're finishing up Unit 5 today, 5B, and on Wednesday you will have a test. I'll probably have a little review Wednesday at 6 o'clock, and then you guys will have your last unit test at 7 o'clock. Next Monday, all we're doing is reviewing for your final. And then your final is next Wednesday and class will be finished. So anyway, this last unit covers the second part of geometry, and today we'll talk about volume of three-dimensional figures, and we'll also talk about similar triangles and the Pythagorean theorem. All right, so if you're trying to find the volume, that means that you want to know how much something holds, like how much water could you pour into a cylinder, how much cereal could a specific box hold. So you have two types of prisms. Well, there's more than two types of prisms, but the ones that we're looking at are a cube, which simply means it's each of the side lengths are the same, or a rectangular prism that has a different length, base, and height. But anyway, the way you find the volume is the same. Basically, you multiply the three side lengths together. So for a cube, it's the same number. And for a rectangular prism, it's two or three different numbers. All right, so if we multiply the same number together 3 times, it's the same way of saying that we're going to cube it. And then, of course, the rectangular prism, we're just multiplying those 3 numbers, length, width, and height together. All right, so moving on. Here's some notes about volume. Volume is a three-dimensional measurement that represents the amount of space inside a closed three-dimensional shape. To find volume, count the number of unit cubes inside a given shape. If there are units, include units in your final result. Units will always be three-dimensional. For example, cubic feet, cubic inches, cubic yards, so on and so forth. So here we have a cube, which means the length, width, and height are all 4 inches. So if we multiply length, width, and height together, for a cube, the numbers are the same. So it's the same thing as saying 4 cubed. So 4 times 4 is 16, and 16 times 4 is 64, and inches times inches times inches is inches cubed. So this cube could hold 64 cubic inches of whatever, juice, water, sand, so on and so forth. All right, so then look at letter B. Letter B, we have a rectangular prism. So the dimensions are 2 feet by 3 feet by 2.5 feet. So we're simply going to multiply those 3 numbers together. I'm going to turn 2.5 to 2.5. So 2 times 3 is 6, and then we're going to multiply 6 times 2.5. 6 times 2.5, which is 15. Since the units are feet, the answer is 15 cubic feet. That is the volume of a box with side lengths of 2 feet, 3 feet, and 2.5 feet. All right. Also, we can find the volume of cylinders. So, of course, a cylinder, the base of a cylinder is a circle. So when you have volume of three-dimensional figures, basically you're finding the area of the base and you're multiplying that area times the height. Well, another way of saying that is capital B times H. Well, capital B means the volume, or excuse me, the area of the base. And how do you find the area of a circle? Pi r squared. The area of the circle is pi r squared. So that capital B represents the area of the base times the height. All right, so in this situation, we don't have a number for the radius. We're just using the letter R. So I assume they're about to give us an example that gives us actual dimensions. All right, here we go. So for example 2, we're going to find the volume of the cylinder. So like I said, the first thing we're going to do is find the area of the circle. So we're going to start with pi r squared. And then we're going to multiply the area of the base by the height. So we're going to use 3.14 for pi. We're going to multiply that by our radius squared. Well, our radius is 6, and 6 squared is 36. And the height of our cylinder is 12 centimeters. So we're just going to throw all that right in our calculator. 3.14 times 36 times 12 is 1,356.48 centimeters cubed. Because once again, we're finding the volume, and so your units are cubic units. Oh, all right, so you guys try these couple of problems on your own. So pause the video, see what you come up with, and then come back and check your answer. All right, so practice 1A, we have a cube, which means all the dimensions are the same size. So we're going to multiply 3.81. We're going to raise it to the third power. .81 times 3.81. And so the volume of this cube is 55. Oh, the directions say round your answers to the nearest integer. That means the nearest ones place. So we have, on my calculator, I have 55.3. So rounded to the nearest ones place is about 55 cubic feet. That should be a 3. All right. What about this rectangular prism? We have 64 meters by 6 meters by 6 meters. So it shows us that the ends are squares because the dimensions are the same. But the height of the prism is 64. So we're going to multiply 6 times 6 times 64. And we get 2,304 meters cubed. That is the volume of that rectangular prism. And then letter B, these are all cylinders. So we're going to find the area of the base. So it tells us to use 3.14 for pi, and it says round our answers to the nearest hundredths. All right, so first of all, we're going to find the area of the base and then multiply it by the height. So we're going to do 3.14 times 11 squared times 27. So that parentheses, of course, means multiplication. So that's just a big multiplication problem. So we're going to do 3.14 times 11 squared times 27. So the first one is 10,258.38 cubic centimeters. All right, and then the second one, if the diameter is 18, what is the radius? The radius is 9, right? So we're going to multiply 3.14 times 9 squared times 18. So 3.14 times 9 squared times 18 is the height. And we get 4,578.12 inches cubed. That's the volume of the middle one. And then finally, the last one, we have to find the area of the base. This is on its side. So remember, 64 is the diameter. So half of 64 would be 32. So our radius is 32. So we're going to multiply 3.14 times 32 squared times 31. So 3.14 times 32 squared times 31. We got 99,676.16 inches cubed. That's a comma. All right. So hopefully you guys got those right. All right, now we also have other types of three-dimensional figures, such as a sphere, a cone, and a pyramid. So of course a pyramid, so you guys know a sphere is like the earth, a cone, everybody knows an ice cream cone, and then a pyramid simply means it's a figure whose sides are triangles. So, most commonly, I guess you could say, I'm not a good drawer, but very often you'll have a square base pyramid like this one. The base has all the same side lengths, or we'll have a rectangular pyramid. Now you could have other types of pyramids. You could have a hexagonal pyramid. You could have, different sides. I mean, the bottom is different shapes. But like I said, the thing that makes it a pyramid is that all the sides are triangles, okay? Probably the two most common that you'll have to find volume for are either square-based pyramids or rectangular pyramids, and that's the ones that we'll talk about in today's examples. All right, so here we have a sphere, and this is the formula defining the volume of a sphere. Now my calculator is a fraction button, 4/3, I can type it in, but I'm going to show you if you only have a common calculator with just, this simple add, subtract, multiply, divide buttons. I'm going to show you the easiest way to plug that into your calculator if you don't have a fraction button. You never want to multiply by a non-terminating decimal though. So 4/3 is 1 1/3. Or 1.3333. So you don't want to multiply by 1.3333 because it's a non-terminating decimal. So we're going to try to make it as close to the real answer as we can get. All right, so if we think about pi and radius as fractions also, we're going to make our whole denominator 3 times 1 times 1 is 3. All right. So then on the top, or the numerator, we're going to multiply 4 times pi, 3.14, and then we're going to multiply that times our radius cubed. Now this time it's not radius squared, it's radius cubed. So our radius of our sphere is 5. So we're going to multiply by 5 to the 3rd power. So the way we're going to do this is we're going to multiply 4 times 3.14 times 5 to the 3rd power, and then that number we're going to divide by 3. Okay, so that's the easiest way to do it when you don't have a fraction button on your calculator. So 4 times 3.14 times 5 times 5 times 5, or 5 raised to the 3rd power. 5 raised to the 3rd power. So we have 1,570, and then the last thing we're going to do is divide by 3. And we get 523 point repeating 3. So if it says normally round to the nearest tenths, it'd be 523.3, or if it said hundredths. And then since it's volume, your units are cubed, okay? So you just use that formula, stick everything in it, and you'll get the right answer. All right, so here we have a square-based pyramid. So a square-based pyramid right here on the bottom. So we're going to, our length, width, and height, since it's square base, those numbers are the same. Or excuse me, the length and the width are the same. And the height of the pyramid is 18. Okay, since it's a square, our length and width are the same. So we're going to think of length, width, and height as a fraction, and we're going to multiply 3 times 1 times 1 times 1. So our denominator is just a 3. So we're going to use our fraction 1 times our length and width are both 10. So we're going to do 10 times 10. And then a height of the pyramid, remember it's got to be a 90-degree angle. So there's the 90-degree angle. The height of this pyramid is 18. So I'm going to go this way because I'm out of room. So 1 times 10 times 10 times 18 is 1,800. All of that divided by 3. And so the volume is 600 cubic centimeters. And that's a square-based pyramid. All right. All right, now you try. So you have one sphere with a radius of 16, and then the radius of this second sphere. What's the radius of the second sphere? It's 8, yes. And then what else do you have? You have an application problem, and then you have some you try problems, A through D. So go ahead and pause the video, try these two problems on the previous page. Try these two problems, or 3 actually, and then the next page, and then come back and check your answer. All right, so letter E says determine the volume of the spheres below. Use 3.14 for pi. Round your answers to the nearest hundredths. So we're going to multiply. Sphere is 4/3 times pi times radius cubed. So we're going to do 4. We're going to have a denominator of 3 times 3.14 times 16 cubed. So we're going to do 4 times 3.14 times 16 to the 3rd power. And then we have 51,445.76, and we're going to divide that number by 3. And we have 1,748 to the hundredths would be 5.9 cubic inches. All right, well, this diameter is half of this one. So do you think our answer will be half of this one? Let's see. All right, so on the second one, we're going to do 4/3 times 3.14 times 8 cubed. So 4 times 3.14 times 8 cubed equals, divided by 3 is 2,000. Oh, wait. I think I wrote my last answer down wrong. Oh, I did. I left out a whole number. This should be 17,148. Yeah, I wrote that wrong because I realized this number, wait, this number is way too small. So this one is 2,143.57. So sorry about that. I got my first one incorrect. I didn't write it right. I didn't write it correctly. And that's a comma. 2,143.57. So is it half? No, it is not half, because 8 cubed is a lot smaller than 16 cubed. A lot smaller. All right, anyway, yeah. All right, so anyway, let's look at our application problem. Renee is interested in buying a hot tub for her backyard and is looking at 2 models from the same company. Model B is roughly in the size of a box with the dimensions 3 by 10 by 4. Model A is roughly in the shape of a cylinder with radius 3 and height of 4. Which one holds a greater volume of water and by how much? So the first one looks like a cube, and the second one is a cylinder, right? So that's 2 different formulas. So the first one, we're just multiplying 3 times 10 times 4. So that'd be 120 feet cubed. And then the second one has a radius of 3. So to find the area of the base, it's pi r squared, and then times 4. So we're going to do 3.14 times 3 squared, which is 9, and then that times 4. So 3.14 times 3 squared times 4 is 113.04 feet cubed. So it says which one holds a greater volume? So it's the rectangular prism holds the greater volume. And by how much? So we would subtract and we would get what? 6.96 cubic feet more if we subtract those. 6.96, I believe. All right, and then on the next page, it says determine the volume of each of the following, include a drawing. All right, so we have a cube, which means all the sides are the same length. They're all 3.25. So we're going to do 3.25 cubed. Basically, we're going to round to the nearest tenths. So my calculator says 34.32. So that would be 34.3 meters cubed. Find the volume of a box with sides of length 4 feet by 2.5 feet by 6. So this time we have a rectangular prism. It's 6 by 4 by, that would be, the side would be 2.5 or 2.5. So we're just going to multiply these numbers together. We have 4 times 6 times 2.5. So that would be 60 feet squared, or cubed, excuse me. And then a can is shaped like a cylinder, right? And let's see, the radius is 4.62. So we're going to do 4.62 squared, because we're going to do pi r cubed, or excuse me, pi r squared, 3.14 times 4.62 squared, and then times the height. So 3.14 times 4.62 squared times 10 is going to be 670.21, so 2 centimeters cubed. And then finally, the third one, or excuse me, letter D, it says find the volume of a sphere. So a sphere is 3-dimensional, but this time the diameter is 12 yards. So what would be the radius? The radius is 6. So the volume of a sphere is 4/3 times pi r cubed. So we're going to do 4 times 3.14, times 6 cubed. So 4 times 3.14 times 6 raised to the third power equals 2,712.96, and we're going to divide that by 3. Answer divided by, oh, I messed up my thing, divided by 3. So here we have 904.32. So since it says to the rounded to the nearest tenth, 904.3 centimeters cubed. And there we have it. All right. Hope y'all did good on that. All right, so example 5 says if you drank soda from 5 cans each with a diameter of 4 inches and a height of 5 inches, how many cubic inches of soda did you drink? So we have a can of soda, which looks like a cylinder. And they tell us that the diameter is 4. So if the diameter is 4, that means the radius has to be 2, correct? And the height is 5. So to find the volume, we're going to do pi times radius squared times h. So we're going to do 3.14 times our radius squared times 5. So 3.14 times 2 squared times 5 equals. So each can is about 62.8 cubic inches, but then we drank 5 of them. So we're going to multiply that number times 5. So we had about 314 cubic inches of soda, which is a lot of salt. A lot of salt. All right, now a cone-shaped pile of sawdust. So we have a cone that's sitting on the floor, and the base of it has a diameter of 38 feet. Woo, that's huge. And this cone is, oh, I'm the worst drawer. This three-dimensional cone is 16 feet tall. 16 feet tall. So it wants to know how big is this cone-shaped pile of sawdust. So on one of our last slides, we saw that the volume of a cone is 1/3 pi times radius squared. A third of that. Because a cylinder is literally 1/3. I mean, 3 times, it holds 3 times more than a cone of the same height and the same diameter. So if you have a can with a specific height and diameter and a cone with the same diameter and the same height, the cone would hold 1/3 as much as the cylinder. So that's where that 1/3 came from. In other words, you could pour 3 cones into that 1 cylinder of liquid. Excuse me. All right, so we're going to do 1, our denominator's 3 times pi, 3.14, times our radius. So if our diameter is 38, what is our radius? Our radius would be 19, right? 19 is half of 38. So we're going to multiply by 19 squared. So 3.14 times 19 squared equals 1133.54. Okay? And then we're going to divide that by 3. So divided by 3 is about 377 point, it didn't tell us what to round it to, so we'll round to the hundredths. So it would be 845, so that'd be 8.5. 846, so we would round it to 0.85. So that's how you find the volume of a cone. Use your formula right there. That's the great thing about formulas. It tells you exactly what to do. All right, so now we're moving on to angles. So we talked about this just a minute on last Wednesday. There's 4 different types of angles. In the top box, you see an acute angle. An acute angle is less than 90 degrees. So a lot of people will say acute little angle to remember that. And the second box shows us a right angle. So right angles are always exactly 90 degrees. If you have an angle greater than 90 degrees, then you have an obtuse angle. And then if you finally have a straight line, it's called a straight angle. And all straight lines have a 180 degree measurement. Okay, so those are the 4 types of angles. All right, so here we have a situation about similar triangles. So Mary was out in the yard one day and had 2 daughters with her. She was doing some renovations and wanted to know how tall the house was. She noticed a shadow 3 feet long when her daughter was standing 12 feet from the house and used it to set up the drawing. So here's the daughter. The daughter is 5 feet tall. Is she? Does it say that? Okay, here's her daughter, and the sun is shining, and she has a shadow. So the daughter has a shadow, and her shadow is 3 feet long. And then here's the side of the house, right? The side of the house, we don't know how tall the house is, but we know that its shadow is 12 feet. This area is 12 feet, but then the entire shadow is 12 plus 3, which is 15 feet. Right? So from here all the way to here is 15 feet. So basically, we could turn this into 2 different triangles. So this is our height of our house, which we don't know what it is. but we know that its shadow is 15 feet long because it's 12 feet to the daughter and then 3 feet past her. And then the daughter, who is shorter, has a shadow that's 3 feet long. And it's telling us right here that the daughter is 5 feet tall. It didn't tell us that in the writing up here that her daughter's 5 feet tall, but it tells us in the picture that it's 5 feet tall. So based on this and the shadow that is being cast by the house and her daughter, we can figure out how tall the building is. Now that's only that one time a day, because as the sun moves, the shadow length is going to change, but it's enough to give us what we need. All right, so we're going to compare, since these are similar triangles, we're going to compare side lengths. So remember when we worked with ratios and proportions? So we're going to say that X corresponds to the height of the daughter. The height of the house corresponds to the height of the daughter, as the shadow of the house corresponds to the shadow of the daughter. So there's our proportion. We're comparing the height of the house to the height of the daughter, shadow of the house to the shadow of the daughter. Okay, so we can't multiply 3 by a whole number to get to 5. That would be easy, but since we can't do that, then we're going to use cross multiplication. So we're going to multiply 3 times x, which is 3x, and 5 times 15, which is 75. And then to get rid of 3 times x, we're going to divide by 3. We got to do the same to both sides. So 75 divided by 3 is 25. So we know that the house is 25 feet tall. 25 feet tall. Okay? All righty. All right, let's look at, is it the same? No, it's exactly the same. It says these triangles are are called similar triangles. They have the same angles and sides in proportion to each other. We can use that information to determine the height of the house. Okay, I didn't realize that's what we were doing. So we found out by comparing similar triangles. All right, let's see what else we need to do. I thought we had another problem to do. Nope, not yet. All right, so then number 6, example 6, use the similar triangles process to determine the length of the missing side. Set up the proportions in as many ways as possible and show the results are all the same. All right, so here is our missing side. So this obviously corresponds to 5. So now we have 2 sets of proportional sides. We could use either of those. We could say that 9 corresponds to what? 3, as x corresponds to 5. We could also say, we could use this other side. We could say that 12 corresponds to 4, as x corresponds to 5. And they're just saying that no matter which one you use, you're going to get the same answer, because both triangles are similar. All right, so since we can't go from 3 to 5 without multiplying by a whole number, we can, however, use cross multiplication. So 3 times x is 3x, 9 times 5 is 45. And then when we divide both sides by 3, we figure out that the missing side is 15. Okay, same thing here. We're going to cross multiply. So 4 times x is 4x. 12 times 5 is 60. And then if we divide both sides by 4, we get the same answer of 15. So those are both different proportions we could use and still get the same answer. All right, so let's look at example 7. We're going to use the similar triangles to determine the length of the missing sides. All right, now notice that this triangle, these are set in the same type, they're exactly set in the same direction. However, this triangle is smaller and it's been flipped from the original. So see this longest side here? We have to make sure that we say that the longest side corresponds to this longest side, which is y. So we're going to say that 52.3 corresponds to y, Now we can't use x in 8.2 because we can't have two unknowns, so we have to use 23.5. 23.5 corresponds to 7.3. Okay, so obviously these are decimals, so we're going to have to cross multiply. So we're going to multiply 52.3 times 7.3, and I get 381.79, and then I cross multiply and I get 23.5y. Then how do you cancel out times 23.5? We're going to divide both sides by 23.5. That goes away. So 381.79 divided by 23.5 is equal to about 16.25. This missing side is about, oh, that's y. So y is about 16.25. But we're not done because we still have an unknown. So we can use this same proportion right here, 23.5. And this time, though, we're going to solve for x. So we're going to say x corresponds to 8.6 as 23.5 corresponds to 7.3. So we're going to cross multiply. X times 7.3 is 7.3x. And then we're going to do 8.6 times 23.5. And we get 202.1. And then we're going to divide both sides by 7.3. So x is equal to about 27.68. So x is equal to about 27.68. 27.68. Alrighty. Oh, and there's an application problem. All right, let me get rid of all this stuff. All right, application example 9. Mary decides to use what she knows about the height of the roof to measure the height of her second daughter. If her second daughter casts a shadow that's 1.5 feet long when she is 13.5 feet from the house, what is the height of the second daughter? Draw an accurate diagram and use similar triangles. All right, so let's see, her second daughter, so here's the daughter. We know that her shadow is 1.5 feet long when she is, how far is she from the house? She is 13.5 feet from the tall house. Mary decides to use what she knows about the height of the roof to measure the height of her daughter. If her second daughter casts a shadow that's 1.3 feet long when she's 13.5 feet from the house, what is the height of the second daughter? Well, I forgot how tall the house is. Do y'all remember how tall the house is? Oh man, I forgot. Oh, wasn't it 25? Yeah, it's 25 feet long, or 25 feet tall, I should say. All right, so the house is 25 feet tall. All right, so let me draw two triangles. All right, so the first triangle has a shadow that is 13.5 plus 1.5, which is 15. And then the daughter, we don't know how tall she is, but we know her little shadow is only 1.5 feet long. All right, so this is easy because if this is 15 and this is 1.5, well, wouldn't this be 2.5? Of course it would be. But let's pretend we don't know. Let's pretend we don't know. So we're going to do 15 goes with 1.5 as 25 goes with x. So we could cross multiply. 25 times 1.5 is 37.5 is equal to 15x. Divide both sides by 15. So 37.5 divided by 15 is 2.5. 2.5 feet. That's it. All right. Okie dokie. My phone is going crazy. All right, so now you guys are going to try, let's see, try those two and letter B and then the next page as well. All right, so you guys try that. Pause, come back and check your answers. And then I'm going to go ahead and take a little break. And then when you start the next video, I'll start answering your questions on this particular section. All right, I'll be back.